Hi, this is a video to talk about our assignment 2 in machine learning subject, and it is practical data analytic project on ID3 algorithm and the decision tree algorithm. I'm gonna talk about our challenges, outputs, ethical potential, and improvements on it. I want to introduce a little bit on decision tree algorithms. Decision trees are the classification of data to achieve the purpose of prediction. A decision tree method first forms a decision tree based on the training set data. If the tree cannot give correct classification to all objects, then some exceptions are added to the training set data, and the process is repeated until the current decision set is formed. The decision tree represents the tree structure of the decision set. We spend a long time to choose a suitable dataset. ID3 does not consider continuous features, such as length, density is a continuous value. They cannot be used in ID3. In addition, ID3 algorithm does not consider the case of missing value and the problem of fitting. So, on the one of our challenges, it is testing the model. We define a new data frame with the defined data called testDF. This data frame have the row which is from 980 to 1010 of DF. The output only shows one split, which might not be the correct answer. We set a high enough recursion depth so it should split out more features. However, we solve a runtime error. Runtime error is occur when the maximum recursion depth exceeded while calling a Python object. We didn't check the stop further splitting conditions in the building of the tree, and it caused my program has been entering recursive function invocation for too many times. Hence, we added the classification method to avoid it. When there are less than 2 samples or the counter reaches the maximum depth, or one side of the split data have a same label, such as good or bad, the classification function will be triggered. This means one of the conditions achieved to stop split in the second splitting. After checking the split data with function split data, it stops splitting. We need to improve the stop further splitting conditions in order to make a better decision tree. So this is our outputs. We use pprint to print the tree out. This output means the best feature we split first is total silver dataset. And we split it with value 12.9 and the dataset will split into two parts. One part only has good quality and another part has the bad quality. And the output only shows one split because of the condition is achieved and it stops splitting. In order to check the current output, we import Graphify. And so we got the visualization output for the text data, which we randomly choose using train test split with an accuracy of 87.2%. After that, we decide to test the in-tree dataset with an accuracy of 85.7%. Okay, for our improvements doing split dataset part, it can have a development that create a cyclic programming to split every attribute. It can be more efficient and accuracy. In the part of our preparing the data, we should choose a appropriate threshold, minimize the classification error rate, and need to further determine the threshold instead of using the mean directly. Also, it is better to extract data which have the features from dataset rather than just inputting all the dataset. This reduces running time and memory space as well as improve efficiency and accuracy. Moreover, in the part of building tree, the model is not showing clearly as it could be. We could use the visualization tools from the scikit-learn library. According to the utilitarian approach, it is following the rule which is considered equally for every entity or stakeholder before making the decision. Decision tree algorithm can help entity to find the best solution or method for each of them. Dataset can help ID3 algorithm and this decision tree algorithm become successful, such as the algorithm can separate the dataset in some parts from multiple conditions and separate step by step until the division condition is reached. So, how about where should we use for ID3 algorithm? This algorithm can suitable for a variety of occasions. For example, it can be useful and efficient in pharmacy or hospital. Doctor can use decision tree algorithm to filter patients for some parts that each part have the same symptom. Then they can take the same symptom patients further screen until no other exceptions. In addition, doctors can also separate medicines for patients who they need same. Another example for using decision tree algorithm can be used in military training. Military instructor can use decision tree algorithm to separate recruits in training, such as recruits can be classified as physical fitness, willpower, execution, and so on. This algorithm allows military instructor to make the suitable training plan for each part of recruits and tap their strengths. Finally, in conclusion, from this we can conclude that decision trees are the process of reducing information uncertainty. We can even think of it as a collection of if-then rules. We can get more information and reduce more uncertainty every time we decide. This is randomness inside a thing that is uncertainty. If a division reduces the uncertainty of a thing, it means that the division can get more information. So this is our video. Thanks for listening. Thank you.